Okay, we now go on to part B of question 14. In part B, we are asked to find the force R exerted by the wall on the ladder. So we are asked to find this force. Okay, at the same time, if you look at the 5 forces acting on the ladder, you'll find that we also do not know what is N, and we also do not know what is F. So there are 3 unknown forces, right? So one trick that is very useful is to take moments about a point through which unknown forces pass, right? So for example, in this case, if I call the bottom of the ladder as A, right? If I take moments about point A, we will find that N and F will not appear in the equation because as far as point A is concerned, the 2 forces N and F do not exert any, do not have any turning effect. So the moment of N or F about point A is 0. So okay, so since the ladder is not rotating, right? So since the ladder is not rotating, it means that it has rotational equilibrium, right? So since the ladder is in rotational equilibrium, okay, we find that the net moment of all forces about point A, the bottom of the ladder, is 0. Right, so let's consider the 3 forces, 800 newtons, 400 newtons, and R, right? N and F pass through point A, and so the moments of these 2 forces about point A is 0, right? So let's consider R first. The moment of R about point A is force times distance, right? The distance that we need to consider is the distance of the line of action of R about point A. So if you were to draw the line of action of R, this is the line of action. Right, we will draw it a bit more clearly. Okay, so this is the so-called line of action of R. Right, so to find the moment of R about point A, we need to find the perpendicular distance of this line of action of R from point A, which is basically this distance, right? So if we take the length of the ladder as L, then this distance will be simply given by L sine 30, right? This is 30 degrees, right? So it's simply L sine 30, right? So L sine 30 will be the perpendicular distance of the line of action of R from the point A, right? And this, and you can see that R exerts an anti-clockwise moment about point A. So that's positive. The 2 remaining forces, 400 newtons and 800 newtons, both exert a clockwise moment about point A, which we calculate, right? So since R exerts an anti-clockwise moment and the 800 and 400 Newton forces exert clockwise moments, these 2 forces will have a negative moment. So let's consider the 400 Newton first. So force times distance. Distance of the 400 Newtons line of action. This is the line of action of the 400 Newton force, right? So the shortest distance, the closest distance, or the perpendicular distance of the line of action of the 400 Newton force from the point A is simply this distance, right? So by simple trigonometry, you can see that this distance is actually L upon 2 cosine 30. Okay, finally we have the 800 Newton force. We also calculate the moment of the 800 Newton force about point A. So similarly, you should be able to see that the perpendicular distance of this line of action is this distance, which is L upon 4 cosine 30 degrees. Right, so the moments of these three forces are 400 Newton and 800 Newton about point A will be 0. Okay, so L is a constant term, so it can be removed from the equation by division, right? And you find that the only unknown is R, which can be found, right? So let's work it out. So R sine 30 will be equals to 400 times half cosine 30